Hi guys, let's look at the next question. At a particular time, when the sun's altitude is 30 degree, the length of the shadow of a vertical tower is 45 meter. So let's just make the tower first, and then in any case, then we'll figure out the position of the sun. Okay, let me change color. Perfect. So this is basically the tower. Perfect. And this the length of shadow. So this is the shadow. I think we've done a question like this. It was question 1 or question 2, which is on shadow. Again, it's making an angle of 90 degree. This angle is 30 degree, and the length of the shadow is 45 meter. Perfect. So where's the sun? Sun is somewhere here, and this is the angle of elevation that it's making. Perfect. So this is basically a straight line, and let's give them some names. So this would be A, B, and C. Next, we need to find the height of the tower. So this angle is given. I need to find the height of the tower. So tan 30 degree is equal to AC upon AB. Tan 30 degree, the value is 1 upon root 3. If I do 1 upon root 3, I'll get into multiplication. So let me just take the value from the log book. So tan 30 degree is 0.5774. So 0.5774 multiplied with AB, which is 45, is equal to AC, which is my length of the tower. So let's multiply 5774 into 45. That would be 20, 35 and 2, 37, 35 and 3, 38, 25 and 3, 28. That's 4 into 4, 16, 4 7s are 28 plus 1, 29, 4 7s are 28 plus 2, 30, and 4 5s are 20 plus 3, 23. So that's 0, 7, 6, 13, that's 10 plus 8, 18. This is 9, this is 5, this is 2. So 259830. How many decimals? 4. That's 1, 2, 3, 4. So that's 25.983. Therefore, AC, which is height of tower, is equal to 25.983 meter. Perfect. This part done. Let's look at the second part. The length of the shadow of the tower when the sun's altitude is 45 degree. So now we have a second part to this question, which says we need to find the length of the shadow of the tower when tan 45 is given. Now again A, B, and C. This time we've already calculated the height of the tower, which is 25.983 meter, and this is 45 degree. This time we need to calculate AB. So again, same trigonometric function, which is tan. So tan 45 degree is equal to AC upon AB. Tan 45 is 1 into AB, which we don't know, which is equal to AC, which is 25.983 meter. Therefore, length of shadow is equal to the height of the tower, which is 25.983 meter. Perfect. Very simple questions. Key part to this question is to be able to draw a rough diagram and then move from there. Next question. The next question that we are doing is question number 10. Question 10 says, two vertical poles are on either side of a road. A 30-meter long ladder is placed between the two poles. When the ladder rests against one pole, it makes something, and when it rests against another pole, it makes something. Calculate the width of the road. Perfect. So there is the same ladder which is being put against two poles. Perfect. So let this be the road, and let this be the ladder, tower 1, rather pole 1, not tower, and let this be pole 2. Perfect. Next, a 30-meter ladder is placed between two poles. When the ladder rests against one pole, it makes an angle of 32 degree 24 minutes with the pole. Okay, so it's making an angle of 32 degree, whereas it makes an angle with the road. Okay, so let's say at this point of time it is making an angle of 32 degree 24 minute with the road. So this is my road, this is 90 degree, this is 90 degree, this is tower 1, or not tower, pole 1, sorry, this is pole 1, this is pole 2. So in one place it makes an angle of 32 degree 24 minute with the pole. Okay, so here it's making an angle of 32 degree 24 minute with the pole. So this is 32 degree 24 minute with the pole, and when it is turned to rest against the other pole, so now this is turned to rest against the other pole, it makes an angle of 32 degree 24 minute with the road. So at one time it is making with the road, at one time it's making with the pole, and this basically is the ladder, which is equal in length, which means this and this are equal. Let's give them some names: A, B, C, D, and E. And BC and CE are basically nothing but the ladder. It's the same ladder. And the length of the ladder is 30 meters. So this is 30 meter. Similarly, this is 30 meter. We need to find the length of the width of the road. So we need to find the value of AC, and then we need to find the value of CD, and we need to add these two. So this time the hypotenuse is given, which means either I can use sine or I can use cos. So let's look at for triangle ABC, what should I use? So if I am looking at triangle ABC, if this is my reference angle, this is an opposite, which means I will use sine. So in triangle ABC, sine 32 degree 24 minute would be equal to AC upon hypotenuse, which is BC. Now let's look at the value of sine 32 degree 24 minute. So this is 0.5358 multiplied with BC. Multiplied with BC is 30, which would be equal to AC. Let's do this multiplication. 5358 multiplied with 3. 3 8s are 24, 15 plus 2 17, 9 plus 1 10, 15 plus 1 16. So that's 16074. How many decimals? 4. 1 2 3 4, but there is a 30, which means 3 decimals. Therefore AC is equal to 16.074 meter. So we've got the width of one part of the road at least. Next, we'll do similar thing in the other triangle. So in triangle CDE, this time this is my reference angle, so then this is adjacent, which means I'll use cos. So cos 32 degree 24 minute would be equal to adjacent, in this case CD, upon hypotenuse, which is CE. Let's look at the log table and figure out the value of cos 32 degree 24 minute. This is equal to 0.8443 multiplied with CE, which is 30, and this is equal to CD. Let's multiply 8443 with 3. That's 9. 3 4s are 12. 12 plus 1 13. 24 plus 1 25. So this is 25.329. Therefore CD is equal to 25.329 meter. Done. As per the question, they want me to find the width of the road. Therefore width of the road is equal to AC plus CD. In this case 16.074 meter plus 25.329 meter, which will be equal to, let's just add this. This is 16.074. 9 plus 4 13. 9 plus 1 10. That's 4. This is 11. That's 41. So 41.403 meter. Perfect. So that's the final answer. The width of the road is 41.403 meter. Let's look at the next question. The next question that we're doing is question number 12. Question number 12 says a man stands 9 meters away from a flagpole. Okay. He observes that the angle of elevation of the top of the tower, top of the pole is something, and angle of depression of the bottom of the pole is something. Oh, so this man has a height then, basically. Perfect, because he's looking at something which is higher than him, and he's looking at something which is at a point which is lower than him. So let's look at, let this be the tower or the pole, and this is the ground. This is the height of the man who's standing, and he is looking at the angle of elevation first, which means I'll have to draw a and then he's looking at an angle of depression. Perfect, which means I'll have to draw the imaginary horizontal here. Perfect, so I think I've got my basic rough diagram correct. Now let's try and solve this question. So this is 90 degree. This is also making an angle of 90 degree. This is also 90. Let's just name this. This is the man. This is pole. The angle of elevation that he's looking at is, this is 9 meter. The angle of elevation of the top of pole is 28 degree, which means this angle is given equal to 28 degree. And then angle of depression, which means, let me remind you, the angle of depression is the angle made when you're at a height and you're looking at something below you, and the angle which is your line of sight makes with the imaginary horizontal. So this angle is 13 degree. Perfect. So now we've got this basic design correct, a basic rough diagram correct. Let's give them some names. So the man would be AB, and the pole could be CDE. This point is C, this point is D, and this point is E. Perfect. So the height of the man is equal to CD. That's basically it. And we need to calculate the height of the pole, which means we will first have to calculate CD and then have to calculate DE. Let's look at this. So since this and this is parallel lines, which means this angle 13 degree is equal to this angle 13 degree, because these are alternate angles. Like I said earlier as well, angle of elevation is always equal to angle of depression. So in this case, angle of depression is 13, which means had I been standing here and looking at the head of the man, the angle of elevation would have been 13 degree. So let's look at first triangle ADE. So in triangle ADE, I need to calculate ED, and this is 9 meter, which means this will also be 9 meter. So let's just write that down. BC is equal to AD is equal to 9 meter. Perfect. So what function could we use? We have the adjacent and we have the opposite, which means tan. So tan 28 degree would be equal to DE upon 9. Tan 28 degree as per your logbook is 0.5317 multiplied with 9 would give me DE. Let's do the multiplication. 5317 multiplied with 9. 7 9s are 63. 9 1 with 6 15. 27 1 28. 45 plus 2 47. How many decimals? 4. 1 2 3 4. So this is 4.7853. Therefore DE is equal to 4.7853 meter. Now next part, we need to find CD, which will be equal to AB. So let's look at this. So in triangle ABC, next would be AB is equal to CD. Perfect. This time again we'll use tan function. So tan 13 degree would be equal to AB upon CB, which is 9. So let's just calculate. Tan 13 degree is equal to 0.2309 multiplied with BC. BC is 9 equal to AB. Let's do this multiplication. 2309 multiplied with 9. 81, that's 8. 27 to carry, 18 plus 2, 20. So that 20781. How many decimals? 4. So this is 2.0781. Therefore, AB is equal to 2.0781 meter. Next, therefore, height of pole will be equal to AB, and this is equal to CD because we've already said AB is equal to CD. So it will be equal to CD plus DE, which is 2.0781 meter plus 4.7853 meter. Let's add 20781 47853. That's 4, 8 plus 5, 13, 8 plus 8, 16. This is 8, this is 6. So this is 6.8634 meter. So height of pole is 6.8634 meter. Good. So interesting question where we had first both angle of elevation as well as angle of depression, and we use the tan function to calculate both of them. Perfect. So in fact, our now that we know that the height of the man is 2 meter, well, he's quite a tall guy, right? 1 meter is approximately 3 feet, 3.3 feet approximately, which means our man is around 6.5 feet tall. That's a long guy, rather tall guy, my mistake. Next, let's look at the last question that we'll do from this exercise. The last question is question number 13. From the top of a cliff, 92 meter high, the angle of depression of a boy is 20 degree. Okay, so let's look at the rough diagram first. So right now we are on the top of a cliff, which means let this be the cliff, and the boy which is coming on the ground, which will be at the sea level here, is making an angle of 20 degree. Perfect. So let this be the boy. Now a common mistake students do is they just directly mark this angle as 20 degree. This will get you -1 in your exam. Reason being, the angle of elevation is not given as 20, angle of depression is given 20, which means you should first draw the imaginary horizontal here. After you've drawn the imaginary horizontal, mark your angle of depression as 20 degree, mark this parallel, and now mark this as 20 degree. Basically what it means is you should definitely show the angle of depression and not directly get into angle of elevation. So this is basically it. This is A, B and C. This is our cliff. This is the boy. And this is the ground. Perfect. Calculate to the nearest meter the distance of the boy from the foot of the hill, which means I need to calculate AB, and the cliff is 92 meter high. Perfect. So again I have a tan function, which means tan 20 degree is equal to AC upon AB. Tan 20 degree in this case is 0.3640 is equal to AC is 92 and AB is what we need to calculate, which means AB would be equal to 92 upon 0.3640. Now this is a very complicated calculations. I think I shared it in the first video of this chapter, which is saying in case you are ever stuck at this kind of a complicated calculation, look at another way of solving it, because dividing by 4 decimal places is slightly longish. So if this angle is 20 degree in triangle ABC, how much would be angle C? Yes, angle C would be 70 degree. So let's just write that down. In triangle ABC, 20 degree plus 90 degree plus angle ACB is equal to 180 degree, which means angle ACB is equal to 70 degree. So now let's look at the reference angle as angle C, which is 70 degree, and see how this works for us, how if it is better, if at all. So tan 70 degree in this case would be opposite, which is AB, upon adjacent, which is AC. value of tan 70 from your book is 2.7475 is equal to AB, which is what we need to calculate, upon AC, which is 92, which means AB is equal to 2.7475 into 92 meter. Slightly easier calculation because it involves multiplication, at least for me. So let's do this multiplication. 27475 multiplied with 92. That's 10. That's 14 plus 1, 15. That's 8 plus 1, 9. That's 14. And that's 4 plus 1, 5. That's 5 nines are 45. That's 7 nines are 63 plus 4, 67. 36 plus 6, 42. 63 plus 4, 67. And 18 plus 6, 24. This is 0. 5 plus 5, 10. That's 10 plus 7, 17. This is 7, 12. That's 2527700. So the answer is 2527700. How many decimals? 1, 2, 3, 4. 1, 2, 3, 4. So this is 252.7700 meter. Now this is the point of time where I should be reading the question once again to figure out what do they want. Because if you leave your answer here, the answer may be wrong. So you read the question now. So the question says calculate to the nearest meter. So they want the answer up to the nearest meter. They don't want the decimal numbers, which means I will round this off since the digit after decimal is more than 5, which means I'll add 1 to the unit digit, which means AB is equal to 253 meter. Perfect. So the answer will be, therefore, the distance is 253 meter. Perfect. So this finishes the exercise. Couple of things that we learned. Number one, angle of elevation, angle of depression. Realized angle of elevation is always equal to angle of depression. And then we use trigonometrical functions to find height, distance in these questions. Another trick, if you can call it, that we learned was if one angle is making your life difficult by getting into a long division, you should look at the second angle of the triangle. This is basically nothing but complementary angles, which is what we've done in class 9. Good, that finishes this exercise. Homework questions for you. Homework for you would be question number 9 part 2, question number 11. Thank you so much. Take care. Be safe. I'll see you with the next video.